In this video, I'm going to talk about tunneling an IP address over L2TP to a Mikrotik device. All Mikrotik devices are going to be configured pretty much the same way, so should work no matter the model that you're using. The architecture looks simply like this. The core transit cloud is on the right. You have an L2TP tunnel service there. When you connect and build that tunnel, it is going to send you a /32 IPv4 address. As you can see, 198.51.100.101 is the address. You notice this is a /32. This can be assigned as a loopback address, or it can be used for NAT. And the way our infrastructure works is it's going to send a route to that destination over the L2TP tunnel, and then you can use that address however you see fit. Of course, if you get a larger block of addresses, you have more flexibility, of course, but a single address like this routed to you is also very flexible. You could use it for NAT, like I mentioned. You can assign it to a loopback. So if you're going to do BGP, assign it to a loopback and then exchange routes with that as your session IP. And you can put anything behind this as well. So we're actually going to do NAT in this example. So our internal host is behind it, and the traffic is going to flow out through this NAT rule that we are going to set up right now. So with that being said, let's dive into the web interface of our Mikrotik device. You will log in at the webfig page. You could also use Winbox if you wanted to. So first things first, when you're brought to a page that looks like this, what you're going to want to do is go to IP and to DHCP client. Now this is if you are using a DHCP client to get your address. You want to go ahead and open this up. Here you can see my DHCP client has IPs assigned. This is on the WAN interface, of course. This could be different in your environment. This could be behind NAT, as in my example, or it could be a public address. Really doesn't matter. One thing we do want to do, though, if we're using DHCP or even static routes, we need to change this default route distance to be something greater than 1. I made mine 10. You can do whatever you want, but it does have to be greater than 1. So go ahead and change that. Hit OK when you're done. The next step is we want to go to the PPP tab on the left-hand side. Go ahead and select that. And then we want to add a new L2TP client. I have the client pre-configured here. You'll notice a few things. Yes, we want to have it enabled. We can add a comment and call it core transit, whatever you want to call it, really doesn't matter. It should get a name by default. L2TP, something like that would be fine. It is going to connect to peering1.dallasfortworth1.coretransit.io. You can see that here. If you're connecting to a different server, again, you're going to put that host name there. You need the username and password that we provided you. This would come in the provisioning email or in the portal for your L2TP session. Each L2TP session is going to have a unique username and password, so keep that in mind. I have default encryption set, which is none. And as we scroll down through here, we notice we want to add a default route. So check that box. And then the default route distance, we want to be 1. And this is a smaller number than that distance that we set for the DHCP client static route. And the reason for this is because when this tunnel comes up, we want the traffic to flow through it. So it needs a lower distance. So that is why we set that value to what we set it to. Once you apply these settings, you should notice that the tunnel status comes up as connected. If it does not, an error message will appear here, and it should have some meaningful details about it. When you come down to the bottom, you will see a local address, and this is from a pool of addresses. This 100.64, an address in that range is going to be from the pool. You'll see the remote address, something like this, will be a public address. And from here, you'll start to see traffic flows on the link. This is even with just a basic configuration. You should see bidirectional traffic fairly quickly once the session is up. Now, this 100.64 address, this is in fact a private address. This is a CGNAT pool address. The reason why we do this is to preserve address space, and in your provisioning email, you will get a IP address that will be yours to use, and the core transit infrastructure will actually route towards your device when the session is live, that block of address space. And again, we used a /32 in our example. Let's jump over and configure a NAT rule to use that address next. To configure a NAT rule, you'll go to IP, open up that, go to Firewall, and then to the NAT tab. Now I have my rule pre-configured. I'm going to open that up and show you what my rule looks like. So the first thing to do when configuring your rule is in fact ensure that it's enabled. The chain will be source NAT. You'll see several options there. Source NAT. Out interface, the L2TP interface that was created earlier. Scroll down here, there's lots of options. Action, source NAT, and then put in that address just like this that we have shared with you in the provisioning email. What this does is because that address is not configured on a physical interface, this just allows traffic to be NATed through that interface. So if you have a client inside, they're going outside through the device, this is the address that they will then use to traverse the internet. And again, it's the source address that is changed. Once the rule is configured, you can scroll down here and actually see traffic that's flowing through the rule. You see I have just a little bit there so far. Ultimately though, once you're happy with your settings, hit apply, and then you should be done. Once you've configured your NAT rule, there will be two. I've actually clicked and dragged my NAT rule to the top of the list to ensure that it is used first. And if for some reason this rule breaks, the default will be a fallback to the default masquerade rule that goes out the WAN interface. So we want to make our rule the top priority. You can simply just drag and drop just like this and move it up to the top. I'm going to leave mine go. There are some performance considerations when sending traffic through a tunnel. We're actually going to go to the Mangle tab as well, and this allows us to manipulate traffic as it flows through our device. I've created a rule here that looks something like this, and this is the Mangle rule. It's enabled. The chain is the forwarding chain, meaning when traffic is forwarded, this will apply. We're going to filter for TCP, and you can probably use some discretion here, but the output interface is all PPP interfaces, so that includes our L2TP interface. We could just as easily pick that interface as well. Scroll down a bit further. We want to look for the TCP MSS value. Use this range to configure it. Look for the SYN flag. And ultimately what we want to do from an action perspective is change the MSS. And the new MSS will be 1400. What this is the segments, the TCP segments, then get shrunk down to ensure that they perform as well as possible through the tunnel. Ultimately, when you're done, you can hit apply and OK. And of course, if you have questions on any of this, certainly open a case with us, but this is in this video as well as our knowledge base configuration guide. One of the most important steps to troubleshooting is the routing table information. So if you go to IP and open that option and click routes, when you look at the routes, there are a few things that I want to point out. First, the first default route here is the WAN side of our device. This is just saying all traffic is going to go there. It has a distance of 10. The next is the default route into the L2TP tunnel that we created with a lower distance, meaning this will be preferred. And this is what we want when the L2TP session is established. We want the traffic to have a shorter distance into the tunnel. If for some reason that session goes down, the other route will take precedence and traffic will continue to flow. You will notice also that there is the bottom one here is the IP address of our tunnel server. Its route is to the default gateway of our WAN interface. And because that is a more specific route than this default above, that will ensure that the tunnel is transported to our tunnel server correctly. Additionally, there's an address inside of the tunnel. You can see that, and some other LAN connected routes as well. But again, this second one here, the default into the tunnel, is the most important. It's probably our most common troubleshooting step. If you have additional questions, check out the link in the video description below to our knowledge base. Of course, I also have a link there where you can go and open a ticket if you continue to have trouble. With that being said, though, I want to thank you for watching and for checking out Core Transit.